In this video on stoichiometry, we're going to build on what we learned when we did mole conversions, and I'm going to teach you how to do gram-to-gram calculations. You're going to need a few things in front of you. You're going to need your white stoichiometry packet, the roadmap that we were using, periodic table, and a calculator. So please get all four of those things out right now: your white packet, your roadmap, your periodic table, and your calculator. If you remember from yesterday, we were dealing with a roadmap that looks something like this, and we were converting between moles of A and moles of B, and I didn't really make my boxes big enough to write in, but you get the idea. We started with moles of A and we went to moles of B. That was a one-step conversion, and we used the mole ratio in order to do that. You were pretty good at that by the end of the period. What we're going to do today is start up here at grams of A and convert to grams of B. In order to do the conversion here and here, you use the molar mass. You already know how to look up the molar mass on the periodic table, and you already know how to convert between grams and moles because we did that in a prior unit. So our problems today are all going to be three-step problems. We're going to start with grams, convert to moles. We're going to do the mole ratio step we learned yesterday, and then we're going to convert from moles to grams to finish the problem off. So please turn in your packet to page 2. And you should see a problem that starts out with car batteries. Car batteries are called lead storage batteries because of their use of large quantities of lead. These batteries utilize the following equation. Now this equation looks pretty complicated, but you don't have to stress over that because it's already balanced for you. Let's read what the first question is asking for. It says if 34.3 grams of lead oxide react, how many grams of water will be formed? So we're starting with grams of lead oxide and we're converting to grams of water. And if we look at that roadmap, I'm not going to draw the whole thing here, but you have it beside you on your table. If you start with grams of lead oxide, the first thing we have to do is convert to moles of lead oxide. So in any stoichiometry problem, I'm going to start with what's given. So we do 34.3 grams of PbO2. And this is going to be a three-step conversion. We know that because we're starting with grams of one substance and we're trying to find grams of another. First thing I'm going to do is convert grams of lead oxide to moles of lead oxide. So I'm going to take this unit and put it on the bottom. Grams of lead oxide to 1 mole of lead oxide. And I'm going to have to add up the molar mass of lead oxide using my periodic table. So 207.2 plus 15.999 times 2 gives me, we'll go with 239.2. Again, I got that number from adding up lead oxide on the periodic table. This unit cancels out, grams of lead oxide. So now I have to take moles of lead oxide and put it on the bottom to cancel out. I'm trying to convert from lead oxide to water, so I'm going to do moles of H2O. The mole ratio in this case would be 1 to 2, so I'm going to, let's see, the 2 is in front of the water. I'm going to put that here. The 1 is down below. This is the step that you learned how to do yesterday. This unit cancels out. We just did that one. Now we have to go from moles of water, so moles of H2O, to grams of H2O. I'm going to put 1 mole on the bottom and cancel that unit. Grams of H2O, the molar mass always comes from the periodic table. So you're going to do 1.0079 times 2 plus 15.999, and you get 18.01. Okay. And now I need to do my math. As you can see, I have my 3 conversion factors set up. The first step is converting from grams to moles. The second step is the mole ratio step. The third step is moles to grams of the new substance that I want. So to do my math, I'm going to take 34.3 divided by 239.2 times 2 times 18.01. and I get 5.17, that rounds to. Grams of H2O, because that's the unit that I'm left with right here. So to answer the question, if 34.3 grams of lead oxide react, how many grams of water will be formed? The answer would be 5.17 grams of water. Now, the next part of the question says, assuming the same mass of lead oxide, how many grams of lead sulfate will be formed? So now what we're looking for is how many grams of lead sulfate are going to be formed. So you have a choice. You can start with the 34.3 grams of lead oxide, or you can start with the 5.17 grams of water. Same type of problem, going to be a three-step stoichiometry problem. It doesn't matter which one you start with. I think I'll just start the same way as I did the last problem. So 34.3 grams PbO2. I have to convert that into moles. So I'm going to do, let's see, grams of PbO2 on the bottom, 1 mole of PbO2 on the top. The molar mass is 239.2. All I did so far was just copy what I had right here. Same step so far. Now we're at this mole ratio step where I have to go from moles of PbO2 to moles of PbSO4. So this unit cancels out. I take moles of PbO2, put it on the bottom, moles of, what am I trying to find? PbSO4, and put it on the top. So on the bottom, I'm going to put a 1. On the top, I'm going to put a 2. Now this unit cancels. Then I have to bring this unit down, moles of PbSO4 and grams of PbSO4. I'm going to look up the molar mass on the periodic table for lead sulfate. So 207.2 plus 32.066 plus 15.999 times 4 gives me 303.3. So 303.3. This unit cancels out. That's 1 mole. So to do the math, again, I'm going to do 34.3 divided by 239.2 times 2 times 303.3. And as my answer, I get, let's see, 86.98. So I'm going to round that to 87.0 grams of PbSO4. So what I want to point out to you here is that this first step is always a molar mass step. Okay, first step is always a molar mass step. Second step is going to be your mole ratio step. Third step is the molar mass step again. When you're doing gram to gram stoichiometry, look, molar mass step, mole ratio step, molar mass step to finish up. Let's do another example. If you turn to page 3, you'll see another problem. Okay. And it starts out with 32.5 grams of zinc sulfate, so go ahead and find that. Okay. So it says 32.5 grams of zinc sulfate reacts to form how many grams of barium sulfate according to the following equation. Don't forget to balance the equation. Well, that's a nice hint that was given to us. So let's take a look at this equation and balance it. I see 2 chlorines here and 2 here. I think this equation is already balanced, so I'm not really sure why that hint was in there. 1 zinc, 1 zinc, 1 sulfate group, 1 sulfate group, 1 barium, 1 barium, 2 chlorines, 2 chlorines. Okay, so this is kind of a trick question a little bit there with that. Don't forget to balance the equation. So we're going to start out with, again, let me read the question, 32.5 grams of zinc sulfate and reacts to form how many grams of barium sulfate? So again, we're going to start the problem with what's given. So we're going to do 32.5 grams of zinc sulfate. This is going to be a 3-step problem. In the first step, I'm going to convert grams to moles. In the second step is my mole ratio step. And in my third step, I'm going to go moles to grams. So I'm going to take this unit and put it on the bottom. Grams of ZnSO4 to 1 mole. And I'm going to look up the molar mass of zinc sulfate. And when I do that, I get 161.5. Grams of zinc sulfate crosses out. I'm going to take this unit down here to cancel. So moles of zinc sulfate to moles of barium sulfate, that's the other substance. I look at the mole ratio. In this case, the mole ratio is 1 to 1. Some people would ask, do I still have to include that step? Yes, absolutely. Then I'm going to take moles of barium sulfate to grams of barium sulfate, and I'm going to add up the molar mass of barium sulfate on the periodic table. And I get 233.4. Okay, so this unit cancels. So if I do my math, 32.5 divided by 161.5 times 233.4, and I get 46.969, so we will make that 47.0 grams of barium sulfate for the answer. So again, molar mass step right here, mole ratio step, molar mass step. When you're using this roadmap, this is the molar mass step. We're going from grams of A to moles of A. That's what we did right here, grams of zinc sulfate to moles of zinc sulfate. Then we do moles of A to moles of B, moles of zinc sulfate to moles of barium sulfate, and then we do moles of B to grams of B, moles of barium sulfate to grams of barium sulfate. This is just molar mass, grams per mole, and this is molar mass, grams per mole. And these ones, we looked in the balanced equation at the coefficients there. That's where we get our mole ratio step from. So there are 3 practice problems for you. What I'm going to do is end this video, start a new video that has some practice problems on from later in your packet. So keep everything handy and look for that next video.